Two pointers, a powerful problem-solving pattern where you initialize two variables and move them towards each other, away from each other, or in the same direction based on the problem. There are currently 210 LeetCode problems tagged with this approach, which shows just how important it is for coding interviews. Using this approach, you can reduce the time complexity of many array and string-related problems from order of n squared to order of n. In this video, I will break down what the two pointers pattern is, types of two pointers, when to use it, and I will walk you through multiple LeetCode problems to help you understand it better. I will also share a resource where you can practice more problems using this pattern. So let's jump in. What is the two pointers pattern? Let's first understand what a pointer is. A pointer is simply a variable that represents an index or position within a data structure, such as an array or linked list. Using pointers at different positions, we can efficiently compare elements and make decisions without relying on nested loops, which would otherwise lead to order of n squared time complexity. The two pointers technique can be applied in different ways, depending on the problem. Let's explore the three most common strategies. First, converging pointers. In this approach, pointers start at opposite ends of a data structure and move inward toward each other. The pointers adjust their positions based on comparisons until a certain condition is met or they cross each other. This strategy is ideal for problems where we need to compare elements from opposite ends of an array or string. For example, checking if a string is a palindrome. A palindrome is a word, phrase, or sequence that reads the same forward and backward. To check if a string is a palindrome, we initialize two pointers, one at the beginning and one at the end. Compare characters at both the pointers. If they match, move both pointers inward. If they don't match, return false. Repeat until the pointers meet. Next, parallel pointers. In this approach, both pointers start at the same end, usually the beginning, and move in the same direction. These pointers generally serve two different but complementary roles. The right pointer is used to explore or find new information, and the left pointer is used to track progress or maintain constraints. Sliding window technique is a popular variation of this approach. In sliding window, two pointers slide across an array or string while maintaining a dynamic range. It's commonly used to find subarrays or substrings that meet specific criteria. I have covered sliding window in a separate video. Feel free to check it out if you want. And the last, trigger-based pointers. In this approach, we move the first pointer independently until it finds an element that meets a certain condition. After this, we start traversing with the second pointer to find additional information related to what the first pointer found. This technique is particularly useful when we need to process elements in stages. A good example of this approach is finding the nth node from the end of a linked list. We move the first pointer n steps forward. Once the first pointer reaches the nth node, initialize the second pointer at the head. Move both pointers one step at a time until the first pointer reaches the end. At this point, the second pointer will be at the nth node from the end. When to use the two pointers pattern? The two pointer algorithm is generally applied to linear data structures such as arrays, strings, or linked lists. A strong clue that a problem can be solved using the two pointers technique is if the input data follows a predictable pattern, such as sorted array or palindromic string. For example, in a sorted array, moving a pointer to the right ensures you are always moving to a greater or equal value, making it easy to compare the values at both the pointers. Another strong indicator that a problem can be solved using two pointers is when it explicitly asks for a pair of values that satisfy a condition, or a result that can be generated from two values. Now let's walk through a few LeetCode problems to understand the two pointers pattern in action. If at any point you feel like pausing the video and trying out the problem yourself, feel free to do so. The first problem is LeetCode 283 move zeros. You are given an integer array, move all zeros to the end of it. You must do this in place without extra space and maintain the relative order of non-zero elements. For this input, the output would be a naive approach would be to create a new temporary array initialized with zeros, then iterate through the original array and copy all non-zero elements to the new array, and finally copy the temporary array to the original array. This works, but it takes extra space equal to the size of the input array. This violates one of the requirements since we have to do it in place. If instead of focusing on moving zeros, we can move all non-zero elements to the left, the zeros will naturally shift to the right. Therefore, we only need to focus on non-zero elements. We can use the two pointers approach to solve this. A right pointer scans the array to find non-zero elements, and a left pointer tracks where the next non-zero element should be placed. When the right pointer finds a non-zero element, we swap it with the element at the left pointer and move both pointers forward. Once the right pointer reaches the end, all zeros will end up at the right end of the array as intended, and all non-zero elements will remain in order. Here is how it looks like in code. Here I am using Java, but you can find the code for other popular programming languages in my GitHub repository called Awesome LeetCode Resources. You can find the link in the description. Start by initializing the left pointer to 0. It will be used to track and place non-zero elements. Iterate over the array using a right pointer to locate non-zero elements. If you find a non-zero element, swap the element at left and right pointer and increment the left pointer. The time complexity of this approach is order of n since we iterate through the array only once. The space complexity is order of 1 since we are not using any extra space. Let's move on to our next problem, LeetCode 11, container with most water. You are given an array where each element represents the height of a vertical line. The goal is to find two lines that can trap the most water between them. In other words, we are looking for the two lines that form the container with the maximum area. The area of water trapped between the two lines depends on two factors: the height of the sorter line, since filling water over the sorter line would result in overflow, and the distance between the two lines. We can calculate the area using the formula min of height at left and height at right times right minus left, where right minus left represents the width of the container. A brute force approach to solve this involves comparing the area found by every possible pair of lines using nested for loops and returning the largest area found. While this works, it has a time complexity of order of n square, which becomes too slow for large inputs. We can optimize this using the two pointers approach, which eliminates the need to compare every pair. Here is the idea. Instead of checking every pair, we start with the widest possible container and gradually reduce the width by moving the pointers inward to find if a larger area can be formed. Start by placing one pointer at the beginning and the other at the end of the array, since the container with the maximum width starts at index 0 and ends at index n-1. Initialize a max area variable to 0 to keep track of the largest area found so far. Iterate while left is less than or equal to right. Calculate the current area using the two lines pointed to by left and right using the formula min at height at left and height at right times right minus left. Update the max area if the current area is greater. Move the pointer that points to the sorter line inward. Why move the pointer at the sorter line? Because moving either pointer inward reduces the width, but the sorter line limits the container's height. Moving the pointer at sorter line inward is the only way to potentially find a taller line, which might increase the area. Repeat this process until the pointers meet. This approach reduces the complexity to order of n, since each element is processed at most once. Here is how it looks like in code. Start by initializing left pointer to 0 and right pointer to the last element. Initialize a variable max area to 0 to store the maximum area found. While left is less than or equal to right, calculate the current area using the formula. Update max area if the current area is greater. Move the pointer pointing to the sorter line inward. If the left line is sorter, increment left, else decrement right. Finally, return the max area. Here are some more LeetCode problems you can practice using this approach. You can find these problems on algomaster.io. Simply head over to the practice page, search for this pattern, or use the filter dropdown and start practicing. On this platform, you can mark problems as complete or star them for later revision. You can also find the links to GitHub and YouTube solutions for each problem. You can check out the full LeetCode patterns playlist here. I hope you found this video helpful. Make sure to subscribe so you won't miss my future videos. Thanks for watching, and I will see you in the next one.